Hey guys, welcome back to the video. So let's continue where we left off. For Bandit 15, the objective is similar, but we will need to have SSL connection instead of just connecting to the raw TCP port. So this means that the service that's listening on 30,001 is going to have SSL encryption. So one way we can do this is using NCAT, because NCAT has the option to support SSL. Netcat and Telnet, these two clients, they do not support SSL, so we cannot use that. So let's try and use NCAT to do this challenge. So this is the command to connect to the localhost port 30,001. So we need to send in the current password, so let's do that. So you can see that we managed to connect to the SSL port successfully, and we were able to get a password for Bandit 16. So another way we can do this without using NCAT, because NCAT might not be installed on the server that you are on the Linux server. So what most Linux server comes with is the OpenSSL command. So we can use OpenSSL command to connect to a SSL port as well. So let's Google how to do that. OpenSSL connect TCP port SSL. Okay, so the command is pretty straightforward. We can just use this. So let's give this a try. We want to connect to the local host and 30,001. Okay, so this is the SSL certificate information on the server. So it's pretty standard information. We can just send in the current password for Bandit 15, and we can see that it's successful as well. So OpenSSL, the command, allows us to connect to SSL port, and we were then able to send in the current password to get the password for the next level. So that's it to this challenge. It's pretty straightforward. So let's continue to Bandit 16 now. Okay, let's check out what is the objective for Bandit 16. Okay, so Bandit 16, we will need to identify a SSL port between 31,000 to 32,000. Okay, so this challenge wants us to perform a port scanning with mmap and then to connect to the SSL port. So is there mmap on this server? Okay, so that's pretty straightforward. We can just do something like a SV scan, and then we can scan on the local host and port 31,000 to 32,000. So SV, so the S is just, SV means that we are doing a version detection. So mmap will do some fingerprinting to identify what is the service behind the port number. So with the mmap help page, it's pretty comprehensive. So you guys can take a look at what are the options that mmap supports. Like for example, the SV that I executed, it will try to determine the service and the version information on the port that it is scanning against. So this could probably take some time, so I might edit the video to make it shorter so that the output comes out faster instead of having to wait for the nmap to finish running. Okay, so the nmap has completed. So we can see that nmap is able to identify the echo service, the SSL echo service, another echo service, and another echo service. So the only port that nmap was not able to identify is on 31790, which is running SSL and has a service of unknown. So nmap was able to fingerprint this banner message from the 31790 port. So you can see that it is asking us for the password. So this is the port that we want to connect to, because it's asking for us to send the current password. So this is one way we can do this, by performing a port scan on nmap. Another way we can do this is actually just to run netstat, so we can see that what are the ports that are listening, and then we can perhaps just try to connect to each and every one of these ports between 31,000 to 32,000, and then just try and sort of like brute force it. But since the objective was to ask us to perform a port scan, so running nmap like this should be the intended way to solve this challenge. So now we know that we should connect to this port, so let's do that. Let's get the SSL command. Let's get the open SSL command to connect to the port. So this is the command. Let's just copy paste it. Now we want to connect to 31,790, and we want to send in the current password. Okay, and we can see that it replies us a correct message and then a private key for SSH connection. So let's save the content of this private key, and then we will create a private key file. And from the previous video, we already know that we need to modify the permission of SSH private key in order to use it. So let's just do that. So this should be the private key for Bandit 17. Okay, so we are in. Let's take a look at what's the objective for level 17. Okay, so two password files, old and new. The password is the only line that has been changed, so we can just use the command diff to identify it. So let's see. Okay, diff password new, and then password old. So I can't recall which one of the arrows refers to a new line, so let's just try both of it. So let's just try the first one first. This will be the password for Bandit 18, either one of it. So let's try the first one. Okay, so the first one works, but the connection to Bandit closed. So why is this? Let's check out. Okay, if you have solved this level and see bye-bye, this is related to so the password is correct, but then this is the challenge for the next level. Okay, so now let's take a look at what's the objective for the next challenge. Okay, the password for the next level is stored in the file readme in home directory. Unfortunately, someone has modified the bash rc file to lock you out when you log in with SSH. That explains it well, why we are getting a bye-bye message, because there's a logout command on the bash rc file. So when we SSH into Bandit 18, we will immediately get disconnected. So SSH, there is a -t option to allow you to execute command. So let's try and do this to see if it works. ifconfig is not okay. So there's a typo in the command. So you can see that we were able to execute ifconfig before we got disconnected. So what this means that we can actually read the password in the readme.txt file before we get disconnected. So let's try and do that. So we can see that even though there is a bash rc command to log us out, we could execute a command upon logging in with SSH with the -t option. So this should be the password for Bandit 19. There's another way to do this. Let's try to open a shell instead. Okay, so this didn't work because I think the bash rc file is implemented and enforced on the bash shell. So maybe let's try the sh shell. Okay, so this works. We were able to authenticate into the server without getting disconnected with the bye-bye message, because we executed a sh shell that isn't affected by the force logout. So we can then read the password file as well. So this is another way that we can solve it. Instead of just running the cat command to read the password file, we could maintain a shell session on the server as the Bandit 18 user. So now we have solved this, let's continue to the next challenge as the Bandit 19 user. Okay, so let's check out what is the objective for Bandit 19. Oh, set UID binary. Okay, so this is a set UID binary. That means the binary will be executed as the owner of the file. So you guys can give the Wikipedia a read. So this should explain better than me. So we should find the binary file here. Okay. So you can see that the SUID bit is set. So what this means that when I execute this, you can see that the effective user ID is actually Bandit 20. So this is really easy since we know that the password is stored in this etc bandit_pass directory. We will be able to read the password for the Bandit 20 user. You can see that we don't have the permission to do so because we are executing this command as the Bandit 19 user, and this file belongs to the Bandit 20 user. But we can use this SUID binary to read the password for the Bandit 20 user because we will be executing this cat command as the Bandit 20 user permission. So you can see that this is how you can solve this challenge. It's pretty easy. So now let's move on to Bandit 20. Alright, let's check out what is the objective for this level. There's a SU binary does the following. It makes a connection to localhost on the port you specify. It then reads a line from the connection and compares it. Okay, I don't really understand what does this do, so let's try to do. This program will connect in. Okay. What does this mean? I don't really understand. So am I supposed to try and connect to every one of the listening port? Is that how it is? Let's try this. If it receives the correct password from the other side, so I shouldn't need to input anything, right? Right, I shouldn't need to input anything, right? Yeah, I think I don't need to input anything. I just need to try and connect to the right port with this binary. Let's just try that. And the pin code, okay, so this is not the port that we want. 30,000, nope. 31, nope. 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 323. Could not connect to 323. Why not? Oh, it's UDP, is it? Yeah, it's UDP. We have tried connecting to all of the port, but nothing seems to work. Okay, this program will connect to the given port using TCP. So how are we going to solve this then? So what should we do? Let's take a look at this again. It receives the correct password. So what password is it that is correct? In the previous level. Okay, so we need a service that will basically echo out the password on the previous level, and then we will connect to it, and then it should print us out the password to the next level. Why not just run strings on this and just try and get the password for this binary? Right, it should be able to do so, right? Okay. That's smart. It's not shown here. Okay, so what do we need to do? We need to set up a listener, right? 8888, and then we will background this, and then let's try and connect to localhost on 8888. Server name not supported. Oh, we just need to specify the port number. Okay. Okay, so we are able to connect to it, but we will need to echo it, echo the password of the current user, right? So one way that we can do this is to echo NE the current password, and then we listen on port 8888, then we background this, and then now if we were to connect to 8888, it should work. It's not working. That's weird. Let's try again, maybe without the NE. So we were able to solve this challenge by setting up a listener on 8888 that will echo out the password for the current level, and then once we connect to this service, this password of the current level will be sent to us, and then this will match, and then the binary will then print out the password for the next level for us. So this is how you can solve level 20. So it's quite tricky, as in the solution is not difficult, but the way the question is being asked is tricky and it's not very straightforward to understand. So another way we can do this is just to have 2 SSH sessions if we don't want to background the listener, so that could work as well. Okay guys, see you in the next video. Take care guys, bye.